Now let's do Docker and Docker Compose mega project. So in this, we will be doing the following activities. Containerize an application, then update the application, then share that application with Docker Hub, and persist the DB, then use bind mounts, and finally do all these things using Docker Compose using simple and attach another MySQL database server service. So we're going to do all those things, but first we will begin with containerize an application. This is what we are going to do. So let's get into our machine. So for rest of this tutorial, you will be working with a simple scheduler list application that is running in node.js. If you are not familiar with node.js, don't at all worry. So don't worry at all. So this guide doesn't require JavaScript experience. To complete this tutorial, you will need the following things. I'm gonna write it here as a prerequisites. Yeah, so here it's Docker and Docker Compose mega project. So prereqs, one, we should have a Docker engine running as well as Docker Compose for letters, and two, we should have a Git client, and three, if you have a Visual Studio Code in your local machine, that's also fine, or we'll use Vim, whichever is fine. That's it. A bit of conceptual understanding about containers and conceptual understanding of containers and images. I hope you have it because we have gone through all those things so far. So first, a first activity, a first task. So total 6 tasks, out of which the first task is to containerize an application. That's our, so task one is to containerize an application. So let's do that. So for that, the first step that we are gonna do is pull our code from the Docker Hub, or you can clone it simply. So let's clone the code. So clone the code from Docker Hub, and then two, write the Docker file and build an image, and four, run the container. That's it. Okay, let's get into the, so here is, so let me install apt update, and after that I'm going to install apt install git option y. So the git has been installed successfully. So let me clear the screen and let me clone the Docker scheduler app deployment. Let me copy this and paste it here. So before that I'm gonna mention git clone. So git clone, it's public repository, so no issue at all. So ls, so it's been cloned into root directory, so I'm gonna push into that mkdir. So here, not okay, mkdir home ubuntu. Here I'm gonna create docker, so shortcut we'll use docker mega project. So docker mp, So now I'm going to push this to there, mv docker to home ubuntu dkr mp. So let's get into the home ubuntu dkr mp and see that here is. So the files has been pushed here. So let's get into that. Cd docker scheduler app deployment and ls, and let's look into the, let's see the contents of it. View the contents of the cloned repository inside the our scheduler app. So here we have docker file that we will do the changes, and readme.md markdown file, and package.json spec and src. This is our source code, and this is arn.lock. Let's see package.json. So I will do cat package.json, and package.json consists of the following data. So it consists of images, license, and main is index.js. This is what the main file, and name is 101 app, and the script's pretty. So this is version is 1.0.0, but this is pretty important. Here you will find all dependencies, that is MySQL 2, SQLite 3, UIT, wait port, and resolution, lot of stuff. Okay, that's enough. So now it's time to build the app's container image. So in order to build the container image, we need to use a Docker file. So a Docker file is simply text-based file with no file extension. So a Docker file contains a script of instructions that Docker uses to create a container image. So in the same directory, in the same location where a package.json file is presented, in the same directory we are going to create a docker file. So vim docker file, here it is. So here we are going to write following code. So we'll go through it one by one. So this is our base image. So here we are going to use our base image. So let me get into docker hub of my repository and click here, and go to the tags and see all, and you see that it's a here. So let me paste it here. Sorry, let me paste it in the sticky note, and here at the docker file section, let me paste it here. So yeah, copy this and rest all remains same. Put it in insert mode and type cube. Yes, that's it. This is our image and project. That's fine. AI Tech work app directory, work there /app. Copy everything in current working directory or present working directory into from the host machine into the /app of the image or container. Then you run arn install this, and finally command is node command with the following argument. So this index.js will be there inside the src. We have to be make sure that, and expose this to 3000. Let me save this wq, and let me cross check ls and cd src, and let me do ls. Yep, index.js, absolutely fine, no issue at all. So let's get back and docker file. So now it's time to build the container image using the docker file. So let's do that. Docker build option T, and it's sked list, and just we'll put sked list and dot. Yeah, let me clear the screen, and yep, now it's fine. That's okay. Sked list option dot build tag Yes, now it's getting built. Done. No, step 2 by okay, step 3 by 7, 4 by 7, 5 by 7. So I think all has been done. The fifth step, okay, two more steps has been left. Yes, the image has been successfully built and it's been tagged as schedule list latest. Okay, so the docker build command uses the docker file to build a new container image. You might have noticed while building it, it had downloaded a lot of layers. This is because you instructed the builder that you wanted to start from the cube churn forward slash note with tag 18 alpine image, but since you did not have that on our machine, docker needed to download that image and after docker, you can see that here after docker downloaded the image, the instructions from the docker file copied in your application and used var and arn to install your application's dependencies. The cmd directive has specifies the default command to run when starting a container from the image. And finally, the option t flag tags your image. Think of this simply as a human readable name for the final image. Since you named the image as sked list, you can refer to that image when you can run a container. So let me do the docker images and we should see our image that is sked list with the latest tag. The dot at the end of the docker build command tells docker that it should look for the docker file in the current directory or present working directory. So now it's time to start an app container. To start an app container, so to do that we will use the docker run command. So let me clear the screen before that, but we need to have a docker images. Yes, so start the container using the docker run and name is fine. Name I'm gonna give, this is scheduler, detached mode, port mapping 3000, sorry, 3000 of host is mapped with 3000 of container. Then name of the image is sked list. That's okay, I will directly copy from there and paste it here, and tag is latest. By default, even if you don't give, it's fine. So we used the d flag here, the d flag to run the new container in detached mode in the background. You can also use the p flag to create a mapping between the host's port 3000 to the container port 3000. Without the port mapping, you wouldn't be able to access the application. Now let's run it. That's it. The container has been built. Now it's time to access it. Let me get into the browser quickly as soon as possible. This is our public IP. Let me make that 3000 the port of host and click enter. Here it is, the mega menu, and this is our scheduler application. You could see that. Yes, here it is. Here we can attach our items. Scheduler, a very simple application. Okay, reduce that 100%. This is fine. Yep, this is it. Yes, how I hope it's looking fantastic. So nicely designed for you. Imlai Charan scheduler. So here we can attach new items. Example, mm, task 1. Now for this mega project, task 1 of the mega project, Docker mega project. So then task 2 of Docker mega project to be done. So add item. This is done. This task 1 has been done. So let me mark it. So task 2 had to be done. Let me leave it like that. Okay. If you want it, you can zoom it and see. It looks brilliant. Nice. Yeah. So that's it. Now let's go ahead and add an item. So we have added it, and at this point we should have a running scheduler app with a few items. It's built by me. If you have followed with me, it is built by you too. So with this, we have successfully completed our task 1 in this. So task 1 is done. Okay, so let me get into this. So task 1 is successful. So now it's task 2. It's time to update the application. Task 2 is to update our application. So our containerized scheduler application. So here we will update the application and container image. We will also learn how to stop and remove the container in this task 2 section. So this consists of, so task 2 to updating the application consists of update the source code, and after that we will remove the whole container, and third we will spin a new container, spin updated container. So this is what we're gonna do. Let's get into the action. So let's begin with updating the source code. So let's jump into our server. Let's zoom it a bit. That's enough. So cd, so ls, yep, we are in the right place in our project directory. So in this first step, we will change the empty text when you don't have any list items to you have no items at and one above. So we're gonna do that. For that we have to find out the app.js. So that is in cd src, and inside the JS script, and inside that you will find that ls and cd s. Okay, where are we now? Then what's the issue? Okay, src, yes. Let me enter into the static and js. Yep, here we can find our app.js. So let me get into that app.js. Okay, that's our file. So let me do vim to app.js. So here it is. So now I'm gonna find out that that line of code that I want to change. So it is at the 56, I think. Let me look there. Let me scroll up a bit, scroll up a bit. So I want to find out that, yeah, 50, 51, 52, 56. Yeah, here you could see the number here. So 56, this is P, a class name is text center, a paragraph tag. So here I'm gonna attach in spite of this. Insert, I put it in insert mode. I will change this to the no items at add one above. In spite of that, I'm gonna change it to the you have no scheduler items, you have no items to be scheduled at add one above. That's how we're gonna change. Okay. So you have no items to be scheduled at add one above. Absolutely fine. That's it. The change has been done. Let me do W, that save, and Q to quit it. So now let's build your updated image using the same command. Let me say docker build option T, and what's the name that we have given? The same name where we're gonna give skid list and dot. So it has thrown an error. It's saying unable to prepare context, unable to evaluate, because we are in a wrong directory. We have to get into place where our Docker file is presented. So here is our Docker file. Now we can give the same command. So image has been successfully built one more time. Now let's spin our container with the updated image. So done. So successfully built. This one is tagged as latest. Let me do docker images. And here it is, sked list with the latest tag. Absolutely latest tag. So let me spin the container now. So docker run detached mode P, and name, I'm gonna give name also. That is, name is, I will give scheduler dp detached mode. Just a minute. Yeah, 3000 should be mapped to the 3000 because we want to go with the same one. And image, it's sked list. Let me copy this and paste it. So default tag only, so I don't need to mention, I guess, but it's better to give tag also. So thrown docker has thrown an error saying error response from daemon conflict. The container name is already in use by container, and you have to remove or rename the container to be able to reuse that name. Okay, we will rebuild with a new name, and we'll see scheduler1. So this time again it has thrown one more error. The error occurred because you aren't able to start the new container while your old container is still running. The reason is that old container is already using the host's port 3000, and only one process on the machine containers included can listen to a specific port. To fix this, you need to remove the old container. So that's what we are gonna do. Before that, let's get into our sticky note. So the first update the source code is done. Now it's time to remove the whole container. So to remove the whole container, you first need to stop it. Once it has stopped, you can remove it. You can remove the whole container using the docker rm command. Sorry. Okay. So but before that, let's do docker ps to get the containers. So the scheduler container, only one container which is running. So now we got the container. Now I'm gonna say docker rm. First we have to stop it. Sorry, docker stop. Either you can use container id, or else you can use a name of the container, but this time I'm gonna use container id, and it's been stopped. No container is running, you see, empty. So let me check the docker ps option here, and here is the scheduler container which is stopped. So now it's time to remove the container. For that, docker rm, here I will use the name of the container, that's a scheduler. The container has been removed. I'll remove one more container, that's scheduler1. So now we should find any container. We should not find any container. So all containers have been deleted, stopped. So Now it's time to start the updated app container. So let us go to the sticky note. The second step in the task 2 also has been executed. Now it's time to spin the updated container. So now we will say docker run. Name of the container I will give just scheduler, no issue at all. Detached mode and port mapping 3000 to 3000 of host to 3000 of container. Then name of the image, name of the image, just a minute. I do not, let me just copy this, clear the screen, docker images. Yeah, so now let me paste it. Now let me copy the name of the image with the tag. That is also updated and latest. That's it. The container has been spinning. Now let's do docker ps. Yes, it's up and spinning. So let's access that application. Let's get into the scheduler. Yes, here it is. This is the old container, so it has to be replaced. Let me see that. Yes, it is. You have no items to be scheduled at add one above. That's how we update the application. You can update anything, whatever you want. It's not a big deal, but I hope you got it. So task one containerizing is done. So click, and task 2, that is updating the application, it's done. So let me mark it, and see, you got the tick. And task 3, sharing the application to Docker Hub, had to be done. So let me leave it like that. This had to be done. These 2 tasks have been done. Okay. Now let's get into the sticky note. Sorry. Yep, here, and take the sticky note. So task 2 has been successfully executed in Docker and Docker Compose Mega project. So then we have the third task, which is sharing the application. So sharing the images. Now that we have built an image, let's share it. Let's share the love. We always share as an Bharatians, as a person from Bharat. We believe in Vasudhaiva Kutumbakam, so we always share love. We spread love, so similarly we spread and we share container images also. That's okay. So to share Docker images, you have to use a Docker registry. So the default registry is Docker Hub, and is where all of the images we have used have come from. So we have been using throughout this course, and we will be using now also, and we will be using further in this course. So the procedure is pretty simple. So let me show you that. Here is my Docker. Yes, here is my Docker account, and here first you sign up or sign in to the Docker. If you do not have an account, you create your own account through sign up, or if you have an account, do sign in to the Docker Hub. Once you got signed into the Docker Hub, then you have to click on a repository and create a repository. And here you can mention the repository name, saying this is sked app. So description, it is scheduler lists tasks. That's it. and let me create, I'll make it public so anybody can access, appears in Docker Hub search. So let me create this. Now this is what is my repository. So once the repository has been made and I have made it public so that you guys also can pull the images from this account. So that's the reason I have made it such a way that, so now to push a new tag to this repository, here they have clearly given the command. So here I'm gonna copy this docker push kubectl. So and I will paste it. Let me open this, and here I'm gonna mention task 3, that is to share the application. In that, sign in and create a repository, and then push the image. That's it, nothing else. It's pretty simple and pretty straightforward. So, and let me copy that command here. So now let's push the image in the command line. Try to running the push command you see on the Docker Hub. So what we're gonna do is, if you simply run, oh, let me get into this. So I will I will try to push now, docker push, and then docker / image name is sked list. So it's throwing an error. Why did it fail? The push command was looking for an image named docker and then sked list, but did not find one. So if you run docker image ls, you won't see such kind of image saying docker / so to do this, to fix this, we need to tag it. We need to tag our existing image we have built to give it another name. So let's do that. Let's tag it first. Okay, let's tag it using docker tag, and name of the image is sked list. Okay, oh sorry, sked list latest. And this I'm gonna make it as, what is the pattern, just let me get into that. So I had to make it in this way. So kubectl is account name, then sked app is a repository name, then after that I have to attach the name. So your account name, let me paste it. Yes, sked list tag, that's fine. So it's been tagged. Now let's do docker image ls, and here is your image. Here is your image. Okay, tag name. Okay, that's my mistake. Sorry. So let me do this as a version 1. Yeah, now docker image ls, and here is that version 1. Forget about that tag name 1. This is what is our image. This is what we're going to push it. But before we push it, as per the security reason, we have to log into that. So docker login option u, and my username, that is cube charan. So it's asking password. Let me give a password to that. So login succeeded. Now I can push it. So docker push, and image name is this. And as usual, version 1, that's a tag. So it's pushing, and let's wait for a while till it gets pushed. Done. Let me refresh it and see that. Here is that sched list and sched app. Here is our image with version 1. That's how you create and you pull, that's how you push your image into the Docker hub, and that's how we share a Docker hub. That's how we share our images into Docker hub. So now this how you can run this simply, anybody can use this, the other anybody else, your friend or your classmates or your a colleague, or anybody else can simply go to your Docker hub account, and pull they can pull this image into their instance, and they can simply say docker run, and they should be able to run it on their system. That's how it makes life much easier. The sharing is always caring, and that we believe Vasudhaiva Kutumbakam. So the activity task 3 has also been completed. So let me underline this also. So now the fourth step is very important step, that is persist the DB. In case you did not notice, our scheduler app is being wiped clean every single time we launched the container. So let me show that. So here is our scheduler app. So this time it's showing task 1, task 2, task 3. That's been done, whereas task 4 had to be done. Whereas this is a new container, but before that we have deployed, after changing code, in after updating our source code, we have done it. But before that we have deployed one more container. In that container we have mentioned task 1 and task 2 only. But when you have when you have spun a new container, the old container items have been completely wiped off. Why why has this been happened? So that's what we're going to see. Let's dive into how the container is working, and we will get to know about this. So the container file system, when a container runs, it uses the various layers from an image for its file system. Each container also gets its own scratch space to create or update or remove files. Any changes won't be seen in another container even if they are using the same image. So that's the reason we don't find this to be persisted, the data to be persisted inside our container. So what's the solution for this? So the solution is, as we have seen, the each container starts from the image definition each time it starts, while containers can create, update and delete files. So those changes are lost when the container is removed, and all changes are isolated to that container. So with volumes, we can change all of this. The solution for this is volumes. So volumes, let me write it in our sticky note. So solution for this is volumes. So volumes provide the ability to connect specific file system paths of the container back to the host machine. If a directory in the container is mounted, changes in the directory are also seen on the host machine. If we mount the same directory across container restarts, we would see the same files. That's the magic. So there are two main types of volumes. We will eventually use both. One is volume mount, and second one is bind mount. So we will begin with volume mounts. So the task 4 is persist the DB with volume mount. Yep. So this is what we are going to see. So persist the scheduler app data. By default, the scheduler app stores its data in a SQLite database. So at which place? /etc and here to do's and to do.db. So in the containers file system, that's where it stores. If you're not familiar with SQLite, no worries again. It's simple. It's a simply relational database. So what is SQLite? SQLite is a relational database in which all of the data is stored in a single file. So while this isn't the best for large scale applications, it works for small demos. So we will talk about switching this to different database engines later in the same project. With the database being a single file, if we can persist that file on the host and make it available to the next container, it should be able to pick up where the last one left off by creating a volume attaching. So often we call this as a mounting. So mounting it to the directory the data is stored in. So we can persist the data this way. As our container writes to the to do.db file, it will be persisted to the host in the volume. As mentioned, we are going to use a volume mount in this case, in this example. So think of in this task, think of a volume mount as an opaque bucket of data. Docker fully manages the volume, including where it is stored on disk. You only need to remember the name of the volume. That's it. That's simple. So here the tasks for us is create a volume with a volume name and remember the name. Remember the volume name. Then attach the volume name and spin the container. That's it. So let's do that. So let's create it. Let's get into the action now. So here is that. So click, okay. Sudo option I clear cd from Ubuntu Docker mega no I do not know ls cd dk rmp yeah okay so let's create a volume by using docker volume command. So docker volume and let's give volume. You can see that when you use a docker volume command, you can manage volumes, create, inspect, ls prune. So we are going to use a create. It creates a volume. Well, let me give docker volume and create, and name of this is to do db. To do db, that's the name. So the volume has been created. So let me copy this, the volume name, and paste it with our sticky note so that we can use it later as a reference. Okay, so I think it's the first activity here we are doing. So let me attach this here and yeah, yes, this is our volume name. So now let's stop and remove the existing containers, and because we want to spin a new container. So let me do docker ps. So this is our container. Let me stop that. Docker stop scheduler and it's been stopped. Now it's time to remove the scheduler. So all gone, so no containers now. Some Ubuntu container is there, that also I'll remove. It's not an issue. Docker rm, it's serene hers. So docker ps option, yeah, all gone, all done. So now it's time to mount. Let's start the scheduler app container, but this time we will add the mount option. So docker run name option, it's scheduler, and we will add mount option with that. Detached mode port option remains same, 3000 of host is mapped with 3000 of container. Then we will set up a mount option, mount, and we will give the volume a name and mount it to /etc to dos in the container, which will capture all files created at the path. So mount, so type is volume type, it's not bind, it's not bind mount, so we will give type. Next type is volume, and then so target is etc to dos, and name of the image, oh, name of the image is skid list, I guess. That's okay. Skid list, and version 1 skid list v1 locally. Okay, I did not find docker images, it's skid list latest. Yes, the container has been spun. So docker ps, as it's running well, it's spinning well, no problem at all. So let's get into the browser and check, but we should have been lost the existing. See, at this moment this was run, this application was running inside a previous container. So now all is going to be wiped off because I have spun a new container. That's it, gone, everything is gone. That's what I'm saying, that's what I was saying. So but anyway, our new application is spinning well, no issue at all. So once the container starts up, spins up, runs up, open the app, and let's add a few items to do to our scheduler list. So task 1, that is containerizing application, that is done. So let me add it, let me click, let me check it. And task 2, what's the task 2 for us? Let me get into slide. Update the application, update the application, add it. And task 3 is share the application, add it, done. And task 4 is persisting data volume mounts, add to be done. Let me add it, so add to be done. Okay, so now let's, these things has been added. Now it's time to validate the persistence of data using volume mounts. We just want to cross check whether the data has been persisted or not. So let's stop and remove the container, our scheduler container. Let me get into this. Now let's stop and remove the container for the scheduler app. So we will use docker ps. So our scheduler app is up and running. So now let's stop the container using docker stop and scheduler, and then we will remove the container, docker scheduler. So now let's open the app. So now here we should find, we'll refresh the screen and wait for some time. It's gone. There is no application up and running. So now let's start a new container using the same command from above. So this is the command. So before we have used all options like mount option and all those things, but in spite of that you can use that. If that doesn't work, then you can go with this. Both are similar. So there we have specifically mentioned mount and volume type and all those things, and this is directly have given volume option and then mapped a to do db. That's the volume name. See, I'll show you. That's the volume name. This is a volume name, and then I map it with etc to do's inside the container or image, and this is the image name. So same command in a different way, and let me execute. The container is up and running. So let me get into our browser and see what's gonna happen. Okay, so let's get into a browser and see. So this time it's nothing is there. So let me refresh it, and here is the magic. See that? So the task 1, task 2, task 3 has been done, and task 4 is going on. So the data has been persisted. This is how we can prove it. So if you want, you can go ahead and remove the container when we have done. So let's add a few more tasks here. So task 4, and we'll check for the persistence of those also. Task 4 for us is to use bind mounts. That's our next, sorry, that's task 5, sorry. And add this item also. And task 6 is use Docker Compose to run multi-containers for the same application. Okay, that's it. These are the tasks that we are gonna do for our mega project, Docker and Docker Compose mega project. So hence it's been proved. Congrats, hooray, you have now learned how to persist data that you can see on your screen. It's visible, it's evident. So let's dive into the volume. So a lot of people frequently ask, where is the Docker storing my data when I use a volume? If you want to know, you can use Docker volume inspect. And what's the name of our volume? That's db, to do db. Here it is. So the mount point is this. This is our mount point, and created local label name to do db options and scope. So you can access this mount point. The mount point is the actual location on the disk where the data is stored. Note that on most machines you will need to have a root access to access the disk, access this directory from the host, but that's where it is. So let's get into that place. So cd, and it's an absolute path. And let me do that. ls, you can find this to do db, to do.db. So let me do cat and to do.db, and here is that. You should find varchar36, name varchar36, and the first one is completed. That's okay. Use bind mounts, task 5, you can see the task 5 bind mounts, and you can see task 4 persist data volume mount. Then task 3, you could see share the application, and I'll show you task 2 update the application, and finally task 1 the containerizing the application. That's how your data has been persisted. So we have successfully completed the fourth task 2, that to volume mount. Okay, so now we're going to look into the bind mounts. In the previous task we have talked about, and we used a volume mount to persist data in our database. A volume mount is a great choice when you need somewhere persistent to store your application data. A bind mount is another type of mount which lets you share a directory from host's file system into the container when working on an application. You can use a bind mount to mount source code into the container. The container sees the changes you make to the code immediately. As soon as you save a file, this means that you can run processes in the container that watch for file system changes and respond to them. So in this task fifth, we will see how can we use bind mounts and a tool called NodeMon to watch for file changes and then restart the application automatically. There are equivalent tools in most other languages and frameworks, but we will do with NodeMon. So before that, what we're gonna do is we will try out bind mounts. So before we looking at how can we use bind mount for developing our application, let's run a quick experiment to get a practical understanding of how bind mounts works. So let's get into our server. So clear the screen and do ls, and we are in the project directory or app directory. So in this we will run the following command. Yes. So what it does, we have to run this command. So run the following command to start bash in an Ubuntu container with a bind mount. So here you can clearly see the first option is bind mount option. The mount option tells Docker to create a bind mount, whereas src, you can see that here src is the current working directory on your host machine. That's the scheduler app deployment directory, and the target here is where the directory should appear inside the container, that is /src inside the container. So after running the command, Docker starts an interactive bash that you can see. This is root and this is ID of the container. This is not, we are not inside the host, we are inside the host machine's container. You see that this is containers, and this one is host machines, and this one is containers. So let's let's create a file. Let's look into the file system of the container. Okay, so let's do the pwd to find out where we are inside the container. We are inside the root directory, absolutely inside the root directory or root virtual directory. And then let's do ls to see the file system of the container. Oh, it's fantastic. It's similar to the container. It's similar to the Linux. Of course, it will be similar to the Linux. It's a Ubuntu. So that's why I always say a container is a miniature Linux OS, a Linux distribution, nothing else. Everything. It's a miniature virtual machine, and it will have all, not all, a miniature level of services and miniature level of utilities inside that, and then file system remains same. Now change the directory in the src directory. Now let's change. So this is okay. We will get into the cd src. What's the issue? Oh, okay. There might be a lot of, yeah. So that utility itself is not there. That's fine. So we have entered into the src, and you could see the files of our project. So here, let's create a new file named touch and test.txt, and let me say ls, and you could see the test.txt here. Okay, this is in our container. Now if you open this directory on the host, we should see the similar file in the similar or the attached directory, the bind mounted directory. For that, we have to get into the host, and once we get into the host, we cannot come back because the container will be in exited state. Okay, but let's see. Let's get out of this and do ls, and here is that test.txt in host machine. This is host machines, and this is container machine. It's a container, and the test.txt, and this is host machine test.txt. So now let's use the same command to enter into that. Yes, now let me do cd src and ls. You could see the test.txt. Now let me get out of this, and we are here. So now I'm going to create a file. So now we are going to create a file, or let me delete this file, and the file should be deleted there. Okay. For that, what I'm going to do is rm and rf test.txt. Yes, ls, it's gone. Now let's run the container and do ls cd src ls. It's gone. It's gone. It's gone. It's gone. It's gone. My file is gone. So that's the power of bind mounts. That's the power of data persistence. I hope you got the clear-cut understanding of bind mounts. Now let's do this with our, let me exit out of this, and let's do this for our application. So let's run our app in a development container. So prerequisites are, the things to be done here is mount out the source code into the container, install all dependencies, and let's start nodemon to watch for file system changes. So let's do this, and make sure no container is running. That scheduler app container is running. Docker ps, I've stopped it, docker, and I have removed it also. I hope yes, these are all Ubuntu command, Ubuntu, basically Ubuntu containers. So let me remove all these things. Docker, Ubuntu, so amazing, objective Tesla, and cool Tesla. So ls all has been deleted. Sorry, Docker ps option A, yeah, all gone. Clear the screen, and here also you could see our application is not at all running. Now let's start. So let's run our container with a specific command. So I'll copy this and I'll paste it here, and it's unable to find image, but that's okay. And finally it's been created our container. So let me check docker ps option A, docker ps. Yeah, so our container is up and running. So here let's go through the command one more time. So whatever we have mentioned. So in this, the first one is a mapping. So it's similar, run in detached mode and create a port mapping, and after that we have w option. You can see w option and /app. This sets the working directory or the current directory that the command will run from. Then we have mount option, the type is bind, and src, that is pwd, and target is /app. This says bind mount the current directory from the host into the /app directory in the container. Then we have used node 18 alpine, directly that image, the image to use. Note this is the base image for our app from the Docker file. And last, we have just run it. sh option C, rn install and rn dev. So the command we are starting using a shell using sh, that is Alpine, and because Alpine doesn't have bash, and running air install to install packages, and then running air run dev to start the development server. So now if you look in the package.json, we will see the dev script starts nodemon. So let's look into the package.json, uh, cat package.json, and you see that dev dependencies. You could see the nodemon version 2.0.20. That's what I was saying. So now we can watch the logs using Docker logs. Just watch the logs for this. Docker logs, and option F in the container name is okay. So let me check that. Docker PS. So the container name is fervent burnel. So Docker logs and option F and fervent burner. So we can see the logs now. So when you're we can watch the logs. It's nodemon 2.0.2 is up. So to restart at any time, enter rs. So watching path, this is current working directory, and watching extension js, mjs, and json, and starting node at this point using this src index.js. Okay, and using SQLite database at here we have the todo.db in etc. So that we'll copy this. We can use this later. I'll paste it here. Yes. So it's listening to on port 3000. Let me check whether it is listening or not. Here it is, up and running. Fantastic. Yeah. So now let's do control plus C to get out of this. Yes, the logs has been gone. Now let's do some changes to the app. For that, I have to get into okay cd and src static js, and let me do vim app.js. So I want to get into line 109. It's 59, 69, 75, 80, 90, 99, 109. Yes. So in this line here I have add item. In spite of the add item, I'm gonna make it item. That's it, item. Or uh, task is also fine. Let me put task. That's okay. Add task. In spite of add item, add task. Yeah. So now let's save this wq. So let's save the file. It's been saved. Let's refresh the page in your web browser, in my web browser, and all you should, and we should see the change reflected almost immediately. Let's check that what's gonna happen. And 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 that's the magic. Add task here. Add task. So so that's how it helps. It's been changed. So if you want to do more changes, you can do it, but without doing any changes, without stopping the container, without rerunning the container, just bind mounting and using Node.man, we are able to do changes. So that's how we developers basically use the tools, use this bind mount tools to continuously upgrade the code and update the code and do the code changes to do the changes to the source code, and simply we get into that. So simply we make all those changes, and the data will be updated, and then file we can do the changes in our file. So this is how we do a lot of experiments in dev stage. So let's with this we have successfully demonstrated bind mounts also. Point we have been working with single container apps, but we now want to add MySQL to the application stack. So the following question often arises: where will MySQL run? Install it in the same container or run it separately? In general, each container should do one thing to do it well. So there is a good chance you would have to scale APIs and front ends differently than databases. Separate containers let you version and update versions in isolation. While you may use a container for databases locally, you may want to use a managed service for the database in production. You don't want to ship your database engine with your app then. So running multiple processes will require a process manager. The container only starts one process, which adds complexity to container startup or shutdown. And there are more reasons. So we will update our application to work like this scheduler app, and it's connected with MySQL. So scheduler app container and MySQL app container, and both will be connected together. That too, we will use Docker Compose. Docker Compose. Using Docker Compose, we are gonna do this. So what is a Docker Compose? We have gone through it, but let me repeat it one more time. A Docker Compose is a tool that was developed to help define and share multi-container applications. With Compose, we can create a YAML file to define the services, and with a single command can spin everything up or tear it all down. The big advantage of using Compose is you can define your application stack in a file, keep it at the root of your project repo. It's now version control and easily enable someone else to contribute to your project. Someone would only need to clone your repo and start the Compose app. In fact, you might see acquired a few projects on GitHub or GitLab doing exactly this now. So the requirements for this project, for this task, that's so task 5 is also done. Now task 6 is use Docker Compose for multi containers. So requirements: Docker Compose should be installed with addition, as we have Docker already, so we need to have a Docker Compose additionally. So, and then the next step that we're gonna do is we have to create a Docker compose.yaml file, and inside that we have to define our services. So here we have two services, so we are going to define two services inside that. So once the services and relative respective information has been given, so then we have to do Docker compose up. That's it. That's what we're going to do in this task. So now let's get into the action now. So let me get into my machine. So it's gone. Let me clear the screen. Sudo I, enter home, Ubuntu, cd, dkrmp, cd, whatever is that. Okay, we are in the proper project directory. So now let me check whether I have Docker Compose or not. Docker Compose and version. Here it is. I have Docker Compose version v2.15.1. If you do not have, kindly install it. But if you're not sure how to do it, just watch my video, watch my Docker part 2. So in that you will find it. So at the root of our project at the root of our scheduler app project. We're going to create a file named docker compose. So vim docker compose dot yml, docker compose dot yml, and let me execute it. So in this compose file, we'll start off by defining the list of services or containers so we want to run as part of our application. So here we're going to mention the list of services first. So I will write insert mode. I'll put it in insert mode and services, services, and colon. So okay, this is not good way of doing. So uh, let me do this in here. Let me do this here, and then let me get back to the, I'll copy this and I'll paste it inside our server. Okay, that would be better. So services, yep. Yeah, services. So now we'll start migrating the service at a time into the compose file. So first thing is the what's our first service? Our first service is scheduler app. For scheduler app, so we will define our scheduler app entry using the image. So for that, what we're gonna do is we will write this as app. That's the identification of the scheduler app service. Then let me add image here directly. So image, let me get into the server first, and I'll do docker ps, sorry, docker images, and I will go with the scheduler kubectl scheduler list version 1. I think that has been pushed. Yes, let me check the repositories. Yeah, scale list and see all. Yeah, it's correct. So let me use that here, paste it with I want here to have that node. So let me look into the node. It's not scheduler app directly. Yes, node is here. See all. Copy this and paste it here. So this is what my image, and so we have given our image which will be useful when defining our MySQL service. Now let's add a few more things. Let's typically we'll see the command close to the image definition. So although there is no requirement on ordering, so let's go ahead and move that into our YAML file. So here we will write a command. The command here is sh, the same command that we have mentioned while we are running the container. So that we are going to mention here, that is command here is sh, because that's node, it uses sh, and air install and ampersand air run. Then we have dev, and let me close it. That's it. That's what our command. Then port mapping is to be given. So let me say ports, and so it's a list of ports we can give. How many you want you can give, but here we are giving only 3000 of host mapped with the 3000 of the container. So then what will we do is we will look into the working directory now. So this is done. Then we'll attach a working directory. For that, it's pretty simple. We have to give working underscore dir, and it's /app. Then volumes, we are attaching the volumes. So it's a volume is a list of volumes again. So dot, the present working directory should be mapped with the working directory of the container or image, that is this. Then finally we need to migrate the environment variables. Finally we need to attach the environment variables to the environment variables to our Docker Compose. So that we have to write environment. Yeah, here it is, and we got the sample. It's a list of variables that we are going to attach. So this is how we are going to do. Okay, either we can give direct list or simply we can write without mentioning the list. So in this case, as these are all key value pairs, so I'm not going to give as a list. Here I'm going to write as a normal dict. If it is a dictionary, how do you mention it? The same way I'm going to write. So let me go to the tab. Yeah, it's not. That's enough. Yeah, no cap. My SQL host. It is name of that is MySQL. No. Small. MySQL. Then next variable is MySQL user. It's root user. Then I'll give MySQL password. It's MySQL password. This is just a secret pass or secret. Then we have MySQL DB. So here I'm gonna give to do as to do's. So that's it. We have defined information that is related to the first service, that is app. So let me save this. So now we will define the MySQL service. So for the MySQL service, we have to attach the service name as, here come services, yes, app at the same indentation level. So I will write it as MySQL. That's the name I'm going to give, because here we have mentioned MySQL and the same name I'm going to attach here. So then image, we will give, I have image, I guess, image, and we'll give MySQL, that's fine. MySQL and 8.0. It's 8.0. Then, so we will attach more things. So we will attach volumes. This time it's to do MySQL data volumes, and we have to define that volume also. So volume, sorry, it's volumes, and it's a list to do's MySQL data and where lib MySQL. That's where we want to attach. Done. So, and finally the last one, it's not a service, it should be equal indentation to the services, that is our volumes. We are attaching specifically volumes. So volumes, it is to do MySQL data. Yeah, and let me give this. So finally we only need to specify the environment variables. That's it, environment variables for MySQL. So I'm going to attach environment variables. Environment, sorry, not entry point, it's environment. Yeah, environment, it's correct. Environment. Yeah, so here it is MySQL root password we have given that, that's a secret. Then MySQL database name, it's again MySQL database. It's to do's. Yeah, I think it's all done. So both the services and related information has been given. At this point, our complete Docker compose.yaml is this. You can see that. Let me cross check one by one at all point. So begin with services. The first is app, and then image name, then command, then ports 3000 is mapped with the 3000 and working dir. Volumes is been attached. This is volume. This is working dir and volumes has been attached, and using bind mount. This is bind mount. And here the environment variables, that should be common because it's a MySQL environment variables. So we want to attach this with our app image. So that's the reason we have mentioned here. And basically MySQL password and MySQL DB is common. And MySQL, then second service is MySQL. That is, we have used image directly MySQL 8.0 and volumes to do. Oh, this is the mistake. MySQL. It's MySQL. To do MySQL. Let me check the spellings one more time. Okay, rest all fine. MySQL secret to do's. Okay, everything is okay. Yep. Then we have mentioned the volumes. To do MySQL data, this is a volume mount, and here you have seen a bind mount, and but this is a volume mount, and that's why, as it is a volume mount, you have to specifically mention that volume name here. And as usual, you have mentioned the environment variables here. That's it. Now it's time to run the application stack, but before that we have to update this. So all these tasks, Docker Compose and create the two services is all done. Now it's time to run our application stack. So let me save this. Let me copy this and let me get into our server. Yeah, ls. Now let me create, we have created Vim Docker Compose YAML, and let me paste it here, the whole code. Yes, that's it. This is our Docker compose.yaml file. Let me WQ. Yes, as our Docker compose YAML file is ready, now it's time to make our Docker container stack up. So to start up the application stack, we have to use Docker compose and up. So by adding option D flag, we can run everything in the background. Now let me execute and run. So the networking, as we can see on the screen, you will notice that the volume was created as well as network by default. So Docker Compose automatically creates a network, but if we want to do the same application using a manual way in using only Docker, so it's hell of manual work, hell of time it's gonna take, but here in this case within a second it has created the network for us. Okay, so it may take a few more minutes for you because it has to pull a lot of images. For me, the images has been pulled before only, so I have used the existing images, so that's the reason it took just 0.1.7.6 seconds. So in this case, the Docker Compose automatically created a network specifically for the application stack, so which is why we did not define one in the compose file. We haven't defined any specific network. The compose itself creates that network. So now let's look at that. Here you can see that container Docker scheduler app deployment app1 and container Docker scheduler app deployment MySQL 1. Two things has been started. So create network has been created, then the both the containers has been started. So before we jump into the what containers are running, let's look into the logs. So Docker compose logs and F option. That's it. So you will see the logs from each of the services interleaved into a single stream. This is incredibly useful when you want to watch for timing related issues. Here, the F flag follows the log, so will give you a live output as it is generated. So let's, oh sorry, you can see that the live logs package.json has been used and 101 app and everything has been resolved. So here nodemon has also come into the picture because that's what they mentioned in the package.json, and nodemon basically started the node src index.js. Then waiting for MySQL that 3306, and MySQL also has been connected. Fantastic. So connected to the MySQL DB at host MySQL. Host name is MySQL and then database name is also MySQL and it's properly connected. So let's listening on port 3000. The proper connection has been made to the both the containers. So there is no issue at all now. So now let's look into the, at this point we should able to see our app running in our browser. So this is the previous one, previous container. So now let me remove this. So at this port no container is running, so now let me put 0. So at 3000 port it's running. Now let me and execute. That's it. You see that our application up and running with MySQL database. With MySQL database, not just an application, it's running with an database. So it's listening on port. Now let me come out of this by just saying Control C. Okay, so now I came out of that, and again let us see the, let's refresh it. Yes, here it is. Our application is up and running. So now we're gonna give logs and app logs. I want to get the app lag only. This is just app logs. This is specific to the app. Then look at it, MySQL. I think MySQL is the name that we have given. Yes, this is our MySQL data. So port 3306 socket where run MySQL D, MySQL.socks. That's where it's been connected. Fantastic. So let me do Control C. Now let's do our app stack. Docker PS. Here, let me clear the screen so that it will be much clear. Docker PS, and here is that. One is Docker scheduler app deployment MySQL 1. This is one container, and second one is Docker scheduler app deployment app 1. This is another container. So two containers are up and running, and our application is also up and running in our browser. Here you will see that. That's it. So we have successfully demonstrated the Docker Compose usage for the multi-container, how that creates a network and how you can run all the containers with one command, one and only one command. So Docker Compose have also been done. So now at the beginning, let's tear it all down. Let's stop all things with one container. That's Docker Compose down. So when you're ready to tear it all down, simply run docker compose down, or that's it, and click enter. Everything will be dead. So remote and stopping and all that. Let's check. Docker ps gone. Docker ps option a gone. Gone, gone. Now let's check the application. That also should be gone. That's it. That's it. So with this, we have successfully demonstrated the Docker and Docker Compose Mega project, a multi-container project. Let's wrap this up. Docker and Docker Compose Mega project. After looking at the MySQL database, we will jump into the MySQL database, and there we are going to look into the database that we have created, that was created by the Docker Compose YAML file, and we'll see the different what is there and how can we give SQL queries and everything. So we'll see that, and then we will wrap this up. So let me do Docker Compose up and option D, detached mode. So it's running. So MySQL and both has been running. Let me check Docker PS. Two containers are running at this moment, so our application should be running. So let me refresh it. Yes, it's running. So let's add few commands here. Task 1, add task, and task 2, click on add task, and task 3, new item, click on add task, and task 4, click on add task. That's it. All 4 has been done. So then task 5, task 6. So task 5, that's a bind mount. Task 6 is our Docker Compose. All done. Brilliant. That's it. So now let's get into our MySQL database. Okay. For that, I need to get a MySQL container IP. So what I'm going to do is I'll use docker inspect command and MySQL 1. So this is what my MySQL container IP. If you just want to confirm it, you can just scroll up a bit more and you will find out the Docker Compose. See, you can see everywhere Docker Compose because it's been the labels, the networking, all has been done through the Docker Compose. And here you can find information, the environment variable. See, this is what is required for us, MySQL password, and MySQL password is secret is our password, and remember that is required. So that's it. So now let's get into the and source and destination. So all has been given. So let's do. So we got this. Let me copy this here. IP. Okay. Now to give MySQL queries or to see the MySQL database, we require a MySQL client. So how do you install a MySQL client? If you do not know the exact one, so you just go for apt search and MySQL client or MySQL client. You will find lot. So default MySQL client. So select anyone and then you say apt install MySQL client and option Y. That's it. It's been installed. So now we can enter into MySQL database, and we can use this to give queries to our MySQL database. For that, what I'm going to do is MySQL option H, and oh, we have deleted that. Then before that, I'll give history, and here is that. Uh, yeah, 170 to 20. Okay, let me reconfirm this first. Yeah, it's 17229.02. It's remains same, but still it's a comment. Yeah, now let me run MySQL option H and paste it here. Then root user, will give root, and P and password is secret, and let me enter. Yes, we are inside the MySQL container, so now we can give any commands. So let's begin with show databases. Here it is, database information schema MySQL, and to-dos is our database. Now if you want to connect with that, you mention connect, and it is to-dos. And reading table information for completion of table and column names, you can now turn off this feature to get a quicker start of with option A. So my connection ID is 14 and current database is to do. So we are able to connect with our database also. So if you want to see more, you can go for the status option. So in status option, you can find out information. So current ID is 14. We have a database, that's to-dos database, and current user is this, and more information and more information. So threads 3, questions 40, flush tables 3, open tables 108, and queries per second is 0.046, not that much because we are not doing much there. So let's do some action there, and let's write task 7, that is querying SQL. And now let me run the status again, but this time it has been changed. It is 0.048, the speed from 0.046 to 0.048, and uptime it's been running for 15 minutes and 8 seconds. And system, that's a shell command, and change your MySQL prompt using prompt. So T and care set warnings. So this is how we connect with our database and we query our data.